Hello students, welcome back to the lecture. In this part of the lecture, we'll see how to design a DFA deterministic finite automaton for the case 2. In the case 2, the language L will contain the finite number of strings and all strings are of different length. In the case number 1, where the language contains the finite number of strings of same length, we already have seen that case in the previous lecture. In this lecture, we will look at the language in which we have the finite number of strings, but those strings are of different length. For example, some of these strings are of the length 1 and some of these strings are of the length 2. So let's take it with the help of example. So you have to design a DFA for the language which is given as L equal to set of strings W such that W belongs to sigma star, where the length of the string is given as it is greater than equal to 1 but less than equal to 2. It implies that the language is containing the strings whose length is 1 and the strings whose length is 2. The string is made up of the input alphabet or input symbols A, B. So the elements that will be in the language L are of the strings length 1, that is A only or B only, and strings of the length 2, that is AA, AB, BA and BB. The rest of the strings of sigma star will be rejected by the automaton. Here in this example, we will have the requirements of 4 states. The states that are required here are, that is got a 4 state. Let's say this is the state number 1, this is the state number 2, this is the state number 3, this is the state number 4. So this is our initial state. And this arrow is representing the first input symbol. Similarly, this arrow which is connecting the state number 2 to the state number 3 is representing the second input symbol. And this is representing the third input symbol. Every arrow is representing one input symbol. So from the language, it is clear that the automaton will accept all the strings whose length is 1. That is single A or single B, both are accepted. So by consuming single A or single B, the machine is reaching to the state 2. Therefore, the state 2 will be the final state. So state 2 will be final state in order to accept the string of length 1. But from the language, it is also clear that the automaton is accepting the string of length 2 also. Whereas as a second symbol, we have both the possibilities. That is, at the second position, as the second input symbol, we can have A as well as B. Both should be accepted. So as a second input, A as well as B, both are accepted. Therefore, the state 3 also will be the final state. So in this case, we will have two final states. The state number 2, which is accepting all the strings of the length 1, And the state number 3, that is this one, is accepting all those strings whose length is 2. If there is further input, that is a string of length 3, which can be A or B, that is to be directed to the dead state. So this is the automaton which is accepting the strings whose length is 1 or 2. Let's take one more example. So here in this example, the language given is L is set of strings W such that W belongs to sigma star, and the length of the string is, which is greater than 2 but less than 3. It implies that the automaton is accepting the 2 length strings as well as the 3 length strings. The input alphabet which is given here is A, B. So the elements of the language will be the strings of length 2, that is AA, AB, BA and BB. These strings are of the length 2. Similarly, the automaton is accepting the strings of the length 3 also. The string of 3 length will be AAA, triple B and 6 more combinations of length 3. So here we will have the requirement of 5 states. Let's suppose this is a state number 1, this is a state number 2, this is a state number 3, this is a state number 4, this is a state number 5. So this is the initial state. And this arrow is representing the first input symbol. This is the second input symbol, third input symbol, and the fourth input symbol. According to the language, the string of length 1 are not accepted, therefore state number 2 will not be the final state. But here we can have both the possibilities. The first input symbol can be A or B. State number 2 will not be the final state as the string of length 1 is not accepted. But the second input, which can be A or B, that is a string of length 2, this is a length 1, this is a length 2. So string of length 2 are accepted, therefore the state number 3 will be the final state, which is accepting this string of length 2. So here in this case, this will be the final state. At the same time, the automaton is accepting the strings of the length 3 also, which is here string of length 3. So at the third position, we can have A or B as an input symbol, and that is to be accepted. Therefore, the state 4 also will be the final state. In this automaton, we have two final states. State number 3, which is handling or accepting the strings of the length 2. So this is making the string of length 2 from here to here. This is the length 2. And from this position, this is the length 3. So therefore, state 3 is accepting the string of length 2 and state 4 is accepting the string of length 3. If there is further input, that is the fourth input, first input, second input and third input, and this is the fourth input. Fourth input symbol. So that or those strings are to be rejected. Therefore, we are directing them to the dead state. So this is the automaton which is accepting the strings of length 2 as well as the length 3 over the alphabet sigma equal to A, B. Let's take one more example. So for example, If you have given a language L, which is set of strings W, where W belongs to sigma star, and here the length of this string W is given as it is greater than equal to 1 and less than equal to 3 over the alphabet A comma B. That is, the automaton is accepting string of length 1, length 2 and length 3 all. So here, similar to the previous example, we will have the 5 states. This state number 1, this state number 2, this state number 3, this state number 4 and the state number 5. This is the initial state. And this is the first input symbol, which can be, so let me write the element of the language. Because the single length string are accepted, therefore we will have A comma B here. Length 2 strings are also accepted, therefore we will have the AA, AB, BA and BB. And string length 3 are also accepted, therefore we will have 8 combinations here and so on. It's a finite set. So string length 1 is accepted, which can be A or B, therefore the state 2 will be the final state to accept the strings of length 1. Because this is the final state and the first input alphabet. The string length 2 is also accepted, therefore as a second input, if you are getting A or B, that also is to be accepted. Therefore, state 3 will be the final state. In this question, the strings of length 3 are also accepted. Therefore, if you are getting the third input, which can be either A or B, that also is to be accepted. Therefore, the state 4 will be the final state. If you are getting further input, that is the fourth input onwards, that is to be rejected. Therefore, the further input, if it is A or B, that is to be directed to a dead state. So fourth input onwards, this is the fourth input. So fourth input onwards should be rejected by the automaton. So here in this example, we have 3 final states. State number 2, which is the final state accepting the strings of length 1. State 3 is also final state, which is accepting the string of length 2. So this is length 2. So this is the first length and this is the second length. So state number 3 is accepting the strings of the length 2. Similarly, state 4 is also final state, which is accepting the strings of the length 3. So this is the automaton which is accepting string of length 1, 2 or 3. If this question is modified in which the language is changed here, that is in place of 1 if it is 0, it implies that this automaton is accepting the string of length 0, 1, 2 and 3. So string of length 0 is nothing but the epsilon. It implies that this language is, or this automaton is accepting the epsilon, which is string of length 0. So in order to manage that epsilon, the very first state, which is the initial state, is also to be a final state. So we are making first state as a final state to accept the epsilon. So this question is modified accordingly because the automaton or DFA is now accepting the string length 0, that is the epsilon. Therefore, the very first state will be made as the final state. In the next lecture, we will look at the design of deterministic finite automata for the case 3, in which the language given will have the infinite number of strings. In the case 1, the language had a finite number of strings and all strings were of same length. In the case 2, which we have seen in this slide or this video, the language had a finite number of strings and all strings were of a different length. And in the case number 3, which we will cover in the next lecture, the language will have the infinite number of strings. Thank you very much. If you have any question, any doubt, any comment or suggestion, please write it into the comment box. Thank you very much.